Exercise 9AB. So now we're going to calculus. So remember, there are 4 areas of study that you are required to understand, and you are now in the second part, which is calculus. So calculus will have all the things you learned from last year. You know, stationary points, derivative skills, gradients. All you're doing that might be added on would be what's the meaning of the derivative, which I'll try to emphasize a lot, because that really, derivatives in calculus is 2/3 of your course. Everything you do, every function you have, you can use calculus. That's why every exam question you have, we can make it a calculus question. That's how the exam's going to roll about as well. There's just so much that you can apply calculus in. So that's why if you don't know how to do this, you're not doing yourself a favor, you're sort of knocking yourself out of the game. The first part of your exam 1 is assessing calculus. First part, first question, 2 marks in, that's already your calculus questions. Yeah? So I will try to make sure that your calculus is good, but every year I still struggle to get the idea across on what it is. I keep emphasizing the same thing, and technically, if you understood year 9 linear algebra, so your gradients, it's there. That's all you need to understand. What a gradient is, what a straight line is. The better you understand that, the better the calculus is, easier to understand. Yeah? But you know, I'm going to try to record this and describe the idea, but we're jumping on to 9AB. Somewhere along the way, I'm going to zip through like 3-4 exercises because it's still one skill. It's a power rule, and I'm just going to whip through it and then get to chain rule. That's the next part that you need to know. Yeah? But for today, this is where all the theory comes from. So I'm going to need you to sort of write some notes or whatever it is, try to understand first principles, because though you're not getting assessed on this is last year's point of skill, first principle is what drives everything. It's the understanding of what a gradient is and how that connects to everything else you do. Yeah? So this is where it all is. It's tedious, but the theory is so important for you to get. Yeah? So here we go. Let's have a look. I'm going to try to describe it here. So gradient at each point on the curve. Now, when you do power rule last year, I'll give you an example. This is what you did last year. You had skills where you went y equals, let's say, x squared, and then you learned how to find the derivative. We said find dy dx, right? And then I'm just going to briefly remind you how to do it. You drop the power, drop down the power, you get 2 times x, and that's power minus 1. And you get 2x. Yeah, that was a power rule. But see, there's no point doing that if you don't know what this actually represents and what it means. Yeah? What you're doing, in fact, when you're finding the derivative or you're differentiating, what you're actually doing is you're finding the gradient of a straight line. Okay, so I'm going to say that again. This tells you the gradient of a straight line. That's a key thing to understand. Everything you do, just if you could remember the one thing I keep saying, I said every single year, and I try to drive it in my students every single year, I say when you find the derivative, you are just finding the gradient of a straight line. And why is that important? Because remember, straight lines, you have parallel lines, you have perpendicular lines, you have intersections, you have tangents, you have negative gradient, positive gradient, undefined gradient, zero gradient. All that is going to be applied in this derivative. Yeah? Now, if you have a look at this curve, I've got these points here. The idea is this. When we draw a tangent line, what does a tangent line mean again? What's a tangent line? Hands up. What's a tangent line by description, Luke?
The tangent line is basically I'm pretty sure it's the line of which the derivative is.
Yes, it is, but I just want to know what a tangent line. By basic definition, what is the tangent line, Kate?
It's a line, a straight line that only touches it.
Yes. Okay, so it's a line, and I know this sounds a bit funny because we say it's a line that touches that curve on the surface at one point. We normally call this your tangent line. So when I draw a straight line and it touches, well, that ain't a straight line. It touches this point once. That straight line, we say that's the tangent line. Okay, so the tangent to it, it creates that 90-degree point as well. There's a tangent line to that point, and it only crosses that point once. It doesn't cross anywhere else on that curve at that particular spot. Yeah? And so if we look at the curve at every single point, there are infinite amount of coordinates here. Every coordinate will have a tangent. There's a tangent here, there's a tangent here. They all touch the curve once. So if you think about it, if I drew it here, you get a tangent there. If I drew it here, you get a tangent here. If I drew it here, you get a tangent there. Calculus is the analysis of this. As simple as it is, all you're analyzing is what happens to the curve as you move around. What happens to that tangent line? And what you can see, what kind of gradient is this at this point? This tangent line, what kind of gradient does it have? Is it positive, negative, zero, undefined? What is it? It's positive. And then if I look at this point here, I'm going to put another gradient at that point. Okay, so now it has a straight line. It's still positive, but it's a bit flatter. If I keep going up, okay, the gradient's still positive, but it gets flat, and flatter, and flatter, and flatter, up until you get to the very top. It gets 0, which is what you learned last year. We said that at the stationary point, it just basically was just another name for saying when does it actually curve up to be 0? Because it's positive, positive, but it's small positive. Up until the point it gets to 0. After 0, the gradient becomes negative. See, that's a negative gradient. At every one of these points, if I drew a tangent line, which means a straight line equation, the straight line y equals mx plus c currently has a negative gradient. Negative, negative, it gets really steep at some point, negative steepness, and then it gets a bit flatter. It's still a negative gradient, it's flat, and it gets back to 0. And it goes back up positive again. Okay, so everything that you're doing, when you find the derivative, you're actually finding the gradient of a straight line. And I want you to understand that this is y equals mx plus c. When you find the derivative, this is what you're finding. Okay, and I'm going to explain why that is the case and how that works as well. When you find the derivative, you're just finding out m. And we all know how to do straight line equations from last year, from year 9, from year 10. We can always find the y-intercept and whatnot. All your exam questions will work around straight line equations. That's all it is. When you find the derivative, you're just finding m. Okay, so let's look at our example here when we say 2x. What does that mean? Why dy dx equals 2x? Yeah? All I'm saying here is if I said that's the gradient of a straight line, dy dx, dy dx equals 2x. The problem is right now I don't know where. I'm talking about the gradients because I could have any particular gradient at y equals x squared. Okay. So I just need to know where am I talking about on the x-axis, where is my point, and it'll tell me what the gradient is. So for example, if I draw the graph right now of y equals x squared, this is what the graph looks like. True? It has infinite amount of points to make this curve. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes on. There are infinite amount of points. Now for every point, it has its own straight line. It has its own tangent line. Now if I said I want to know what the gradient of this line is. See, if I drew a tangent line and it touches that point once, that has an equation y equals mx plus c. If I want to know what the gradient is there, at that point, if I told you that I knew the x value was 10. See, if I knew it was 10, I knew x equals 10. I don't need to know what y is. All I need to know is at 10, what's my gradient for the straight line. That's what this is for. See, this will tell you m, the dy dx of an x squared graph, 2 times whatever x is, will tell you what the gradient is. And so what I know now is, okay, well if this is y equals x squared and I just found out the derivative, which is 2x, that just tells me that at x equals 10, so at x equals 10, my gradient would be 2 times 10. That's all it tells me. And this gives me m. So right now I don't know what the y-intercept is, but what I do know, this is what I know. I know the equation is y equals 20x plus c. Does that make sense so far? Or what I'm trying to describe? I haven't explained why that's the case. All I'm saying is when you find the derivative, you get a gradient function. At any x value you want to know, if I want to know what's the gradient at 0, if I want to know what the gradient is at -1 on this curve, that's what the derivative allows me to do. So at x equals 10, at x equals -1, and x equals 0, you plug it into the derivative equation. That tells you n. That's all it does. It doesn't tell you what the y-intercept is. It doesn't tell you anything of the tangent line. It just tells you at that point, I know the gradient is whatever it is equal 1. Okay? How do we feel about that idea so far? Alright? Yeah? Alright. Now let's go to the theory. Why is that the case? Why is it that when we find the derivative, it so magically tells you the gradient, right? That's what first principles is about. That's what last year was about trying to describe, besides learning all the chain rule, product rule. There's no point knowing the rules if you don't know what it means. Yeah? So this is what I'm gonna just rub off the top part here. And I'm gonna go back to this curve. I'm gonna just draw this curve, and I want you to think about this idea. Okay, so let's have a look. Let's go back to your quadratic graph again, because it's a nice, easy graph. Okay. Let's agree that at this point here, I want to know what the gradient of that point is. Okay, so I want to know the tangent line. There's a line that touches this point. I'm going to color it as the blue line. I want to know y equals mx plus c. I want to know what the gradient is. That's what I want. Now, going back to our year 9 maths, how do you find the gradient of a line? How many points do you need to find a gradient? 2. The only one thing you learned in year 9 is to get a gradient you need rise over run. True? Rise over run. Now, number of units you go up versus number of units you go across, that tells you the gradient. So at this point, it's a bit hard because I only got 1 point. How do I find the gradient of 1 point? That's a problem. So this is where first principles comes in. They're like, all right, we have a problem. We can't find the gradient of 1 point because we need rise over run. So they said, why don't I make another point? Why don't I just pick another point? So I say this point, and let's say that point up there. Okay, so I'm going to do it in red now. Let's say I chose this. So this is the first point. I'm going to call it x1. Okay. That means it has a y coordinate of y1. Yeah, so this is x1, y1. Let's say I picked another point, so I can finally make a gradient. x2 will give me a second value, which is y2. Okay, so I want you to see here, I'm picking 2 points. I've got the blue dot, x1, y1, that's the first coordinate. Second coordinate, that's x2. On the parabola, that's y2. Yeah? My job is to find out the gradient of this blue line. Now what I want you to see is that if I pick 2 points, how do you find the gradient of a straight line again? What do you do? If I've got 2 points, how do I find the gradient? What's the formula again? Yes, Jack.
y2 minus y1 over x2 minus x1.
Yeah, that literally just tells you x2 minus x1 just tells you horizontal distance. y2 minus y1 just tells you the vertical distance. That's all you're doing. Like if I colored in green so you could see, all I'm saying is y2, which is here, minus y1, you're just finding out the vertical distance from here to here. And then when I say x2 minus x1, you're really just finding the horizontal distance, hence rise over run. Yeah? So I'm going to write it down. This is what you would have done. You would have said gradient is equal to y2 minus y1 over x2 minus x1. Now what you can see there is that will give me the gradient of this line. I'm going to draw it here. Is that too messy? I'm going to do it maybe in a different color. Let's do purple. See what I'm drawing there? This is a purple line from the blue dot to the red dot. That's the tangent line if I had chosen a random one that was called x2. Okay? Now, that steepness of a line is very different to the steepness of the blue line. Agreed? There's the blue line, purple line. Blue line, purple line. I don't want the purple line, I want the blue line. Now what we can see is because I chose x2 over here, and that's why I created that steepness. Now, if you think about it, if I move x2 a bit closer, if I said, well, what if I chose x2 in between it? If I chose x2, you'll see that, I'll do it again, I'll do a purple line. So if you see, if I made x2 here instead, the gradient now is getting closer and closer, or maybe I'll draw it bigger so you can see. I'll draw it bigger. That's what I mean. Let's do it this way. Let's have a big visual idea of what we're actually doing. Let's say this is the gradient you want. Okay? If I chose this point here, connecting to that, that's what it looks like. If I chose another point closer, and then I chose another one closer, can you see how as I'm getting closer to it, the gradient is starting to look the same? So from here to here, it's very steep. But if I keep it closer and closer, if I make x2 closer, it gets as close as to the line that I want. Does that make sense of what I'm saying there? Is that confusing? Because that's literally the whole theory there. They're just saying, what if I wanted only the gradient of one point? Obviously, the further I take out x2, the line will be too flat out. For me to have exactly the blue line, the closer the x2 is, the closer the gradient is to the actual real one. That's what you want. You want the gradient of the blue line. So if you just made the second point as close to the first point, that will give you the gradient of what you want. True? Okay. So now, in your textbook, how they describe it is they call this point x1. They called the second point, instead of x2, they called it x1 plus h. The reason why they call it x1 plus h is because it's only a certain amount away from x1. So that gives you the second coordinate. So what they're saying is, what if x1 is here? What if you only added a very tiny small amount? If you added only a very small amount and h is just a bit off from x1, you get a second point. Then the question is, if I had a second point that was so close, if this was x1 plus h, if that was it, if you were to draw a straight line between those 2 points and they're so close to each other, it'll be exactly, like in terms of like the approximation, it will be exactly approximated to the straight line. That's what they're trying to say. They're saying, what if h was infinitely small, but it's not 0, it's just so close to x1 that you can say those 2 points, y2 minus y1, x2 is just so close, y1 will be very small as well, the difference between it, hence you get the gradient of this line. Does that make sense? That's what the first principles is describing. Yeah? And so if I went with this idea, if this is x1 plus h, then you get f of x1 plus h to find out the y value. And then if you want the coordinate for x here, then that would be f of x. This is why last year, when you learned first principles, this is what, wait, let me just rub this all off. Here we go. Last year, is what you guys did. You had m equals to y2 minus y1 over x2 minus x1. If I replace everything now, the first coordinate was x1 and then f of x. Yeah? So now I have, this is my y value, y1, x1. If I drew out my second point, it's at x plus h, and the y coordinate for that is f of x plus h. If you did y2 minus y1, so I'm going to do it in red here, so you can see, y2, x2, y1, x1. If you follow that sort of pattern, y2 would be f of x plus h, minus y1, which is f of x, over x2 minus x1, so x2 is currently x plus h, minus x1, which is x. That's why last year, x minus x cancels out, and you get this ugly equation when you first learned calculus. You got f of x plus h minus f of x over h. And the only one thing they added to the first principles they say, okay, this is only, you can only get the gradient of 1 point, because that's the problem. We don't know how to find the gradient of 1 point. You can only do that if h was infinitely small, which is what I was trying to describe over here. I said if you chose h over here, then you get a very wide gradient. So it's very different to the blue line. But if you made h really close to the first one, if h was infinitely small, so approaching 0, you would be able to find the gradient of 1 point. That's what first principles is. So what they added on as a notation, they said limit of h approach 0. You guys remember that equation from last year? Limit of h approach 0. All they're trying to say here is y2 minus y1 over x2 minus x1. What if I made h so small? What if I made those 2 points so close to each other that they're not exactly 0, but if you made it so close, the gradient will be exactly the same as the gradient of 1 point. Okay, so I'll draw it again just to make clarity. I'll do it all again. Yeah. I wish there was a better rubbing system here. Okay, here we go. Yep. Yep, absolutely. Let's do this again. Oh, let's do this again. So I said, you get a graph. So I'm going to draw it again. This is what I get, a graph. Okay. Let's say I want to know the gradient at this point. So I'll call that x, and this will be f of x to find out the y value. Okay. So this is when x is that, f of whatever the x is, that will give me my y value. I want to know the gradient. I'm going to do it in green now so you can see it clear distance. That's the one I want. What we can see is if I choose a second point, which I'll call purple, if I chose over here x plus h, if I just made h, x is here, if I added h amount across, let's say it was over here, you can already see that the second point to find the gradient is too far. You can see if I connected these two dots, it's not the green line. It's not the same as the green line. What if I made h closer and closer and closer? If I made h that second dot right there, that will be very close to the green line. It's more close to the green line than it is further away. So hypothetically, they're saying, what if h was like 0.000001? So if x was 2, so if the distance from here was, let's say that was 2, let's say h was 2.00000001. So if you found the distance between that, it's so small. And the y value is also slightly different too, but that would be the gradient of the green line, because it's y2 minus y1 over x2 minus x1. That's what they're trying to describe there. This is called the first principles. And that's where your power rule comes from, that's where the chain rule comes from. They all derived it from this idea. They're just saying, what if h is so small, that gives you the gradient of the straight line. That's why when you do the power rule, y equals x squared, and you said do y dx, that power rule, all it's doing is it allows you to find the gradient of 1 point. So if you had to write anything from the last almost like 30 minutes of explanation, the only thing you can write down for me is this understanding. dy dx gives you gradient of, 1 point. That's the only thing you got to understand. So throughout year 9, 10, 11, you've only learned so far how to find the gradient with 2 points. You are now allowed, with derivatives, it allows you to find the gradient of 1 point. That's all you're doing. Okay, so you just have to remember, you're just finding the gradient of a straight line. So when you walk out of here today, and when I start explaining calculus later on, every time we do a derivative, I want you to drill it in your head. It is the gradient of a straight line with 1 point. You don't need 2 anymore, you can do 1. With 1 point, you can find the gradient of a straight line at 1 point. Okay, so if out of all that, if what you can understand out of it, just take that line down. Okay, so the derivative allows you to find the gradient with 1 point. 1 point. Okay? And that line is called a tangent line. Right. Okay? All right, let's do some examples now. Let's just get you feeling a bit more confident with the questions here. Let's do, I'm just gonna move, don't worry about this. This is me. Actually, I'll do this so you can see what I was trying to describe. In this first slide, I was trying to get you to revise year 9 gradients. Positive gradient, negative gradient, zero gradient, and undefined gradient. And as you're going around the circle, I mean the cubic graph, you can see positive gradient, zero gradient, negative gradient, zero gradient again, and positive gradient at each point on the curve. Okay? Now, this is what I was trying to describe. That's where the whole thing that I was writing down, x2 minus x1, I tried to describe with a parabola, and that's how you get your first principles. Okay? So I'll just leave it here so you can look at it if you want to copy it down. So I said, if I had a curve that was x squared, okay, I chose a point, if it was x, then the y value would be x squared. When x is x, then y would be x squared. And if it was 2, it'll be 2 squared. If it's 3, it'll be 3 squared. If it's 4, it'll be 4 squared. So if it's x, then it'll be x squared. Because that's what the machine is. Yeah? That's what my function is. So if I chose a second point q, if I called it q, what if I said it was x plus h amount away? That's all I'm saying. So if you think about it, this is what I'm saying. If this q point was x plus h, then this coordinate here would be x plus h and f of x plus h. Or another way of thinking about it is x plus h and x plus h squared. Okay, I know the notation looks scary, but if you read what it means, it just means if the x coordinate was 2, according to the function, you'd square it to get the y value. Then here, if the x value was x plus h, then the y value will be x plus h squared. Okay, I'm just writing that. That's all I'm saying here. If the x value is x plus h, then to find out the y value, we sub into the equation, which is whatever the x is, square it. Yeah? So that's all I did here. y2, x plus h squared, minus y1. This is my y1. X squared. This is my x2, x plus h, minus my x1, x. That cancels out and you get this equation. And the first principle says, what if h becomes really small? All I did here was I expanded the numerator, x squared plus h, x plus h squared, expanded it, I simplified it, so you can see x squared minus x squared cancels out. Down here, x squared minus x squared. I've got the h's, I divide them all by h, and I get 2x plus h. So according to this, they're saying, all right, all of this so far was meant to find your gradient. What if h was so small? 2 times x plus a very, 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 very small number. Because h is a very small number. What if I made h a very small number? Then 2x plus a very insignificant number is 2x. That's what the first principle is trying to say. That's why when you find the derivative of x squared, it was 2x. Yeah? That's where it's coming from. That's what you're trying to say. So there you go. This is why it allows you to find the gradient, and that's what you do in exercise 9A. See 9A, what I'm showing you here is applying the first principles there. Okay, that's what they're trying to get you to understand. You're doing y2 minus y1, you're just trying to find the gradient. So now, on the curve, if I want to know the gradient at x equals -1, I wanted to know the gradient of this straight line. So you got a y equals mx plus c. I can find out m if I knew x was at -1. So therefore m has to be -2. So at x equals -1, I know the gradient at this one point. Remember, all you're doing with the derivative is it allows you to find the gradient at one point. I now know this gradient is -2. So I know this equation of the straight line is y equals -2x plus c. I don't know what the y-intercept is yet, but I know the gradient's -2. That's all you're doing. Yes? Cool? Alright. I'm going to guide you to the next one. Let's start on part B. I want you to try part B. So without using power rule, I want you to find the derivative, or using first principles, find the derivative of 2 minus x cubed. Yep. Say it again?
For the last one.
Yep.
How do you find C?
See, I haven't taught you to find C yet. We will learn to find C, but at this point, well, technically you've learned how to find C. So remember back in year 9, if you had y equals to 3x plus c, the only way for you to find c is you need a coordinate, because it has an x and a y coordinate, true? And you already have a coordinate. If you know x is -1, okay, how do you find the y value? And what's the function? So -1 squared is? So I already got a point. So if I want to find now, if I want to find c, when x is -1, y is 1. Okay, oh sorry, the gradient should have been -2x at -1. Okay, and so if I sub that in, I get 1 equals to -2 times -1 plus c, 2, 1 plus c, and therefore c equals to -1. So therefore now I know the equation. At x equals -1, it is y equals to -2x minus 1. And what I just did with you is chapter 10. How easy is that? See, what I'm trying to say is you understand the concept. This is just year 9 mathematics here. Okay, it's the concept that's really hard to get your head around. But that's tangent lines exercise 10A. Yeah, tangent lines, that's all you just did. You just found out the tangent line at one point. But really, all I taught you was year 9 mathematics here. Yeah, you got m through the derivative. How do you find c? Back in year 9, you sub the coordinate. Where do you get the coordinate? You already knew x. X was -1. How do you find y? Sub it back to the function. You get a coordinate. Coordinate has an x and a y coordinate. Sub it in. Find c. And that's literally chapter 9, chapter 10. Tangent lines. So you got a line. Next one, if they wanted to slice it up in chapter 10, parallel. Perpendicular. They'll say your current tangent line is perpendicular to this line. Find the equation. And you have to go through derivative to find m. Once you know m, find x and y, sub it in to find c. If they want to make it harder in the exam, what do? They give you c. They give you m. They tell you to find the coordinates. Work backwards. Find the coordinates this time. So they don't give you x, they don't give you y. You have to figure it out. They give you a gradient, they give you a y-intercept. But that's all you're doing. It's all straight line equations. And the derivative, all you're doing is finding the gradient. That's all it does. Yeah, so what I just taught you there is chapter 10, exercise 10A. Tangent lines. Pretty simple. Yeah? But for today, all you're doing is learning how to apply first principles. But remember, you're not getting assessed on this at the end of the year. This is just for you to understand what it is, and then you work on that. Yeah, so what I want you to do, I know you can use power rule to find out the derivative there, but I want you to use first principles. Okay, so again, you got f of x, sorry, you got your first coordinate. When it's x, y is f of x. Your second coordinate is what if x was x plus h? What if you moved it x just a bit? If h was just a small amount away, that's your second coordinate there. Then the y value would be f of x plus h. If I replace that, this is x. The next one is 2 minus x cubed, because that's what f of x is. My second coordinate would then be x plus h, that's my x value. Then f of x plus h would be 2 minus x plus h cubed. Have I confused anyone? Yeah, so I'm just saying, it's my first x value. How do I find my y value? As we said before, sub it into the function. So if I put x in here, then I get 2 minus x cubed. At my x1, y1. x1, y1. If I want to find my second coordinate, we're going to make it up. We're going to make h so small away from x so we can find a gradient. So we can only find gradients with 2 points. Yeah? So here, I said, what if I took the original and added an extra bit? So x plus h. If that's my x coordinate, how do you find the y? Sub it into the function. So it's f of x plus h. I sub x plus h into where x is. That's why I now have 2 minus instead of x, I have x plus h cubed. That's where it's coming from. Yeah? This is my y2, that's my x2. I'll write it underneath so you, instead of as I'm explaining, you're not getting confused, but I'll write it underneath. All I'm saying is this is x1, y1, x2, y2. Then you do your first principles. So your first principle says it's to find the gradient, it's y2 minus y1 over x2 minus x1. According to what I have there, y2 is 2 minus bracket x plus h cubed minus, be careful here, I'm using brackets so I don't make mistakes, y1, which is 2 minus x cubed. Over x2 minus x1, this is x2, x plus h, minus x1, x. I'm just using the first principles right now, or your formula from year 9. y2 minus y1, x2 minus x1. This is my y2, minus, now notice I use brackets, because a lot of students don't do this in the exams, and they make a mistake. See, if I don't put the brackets in, it looks like it's just saying minus 2, and then you have minus x cubed. That's wrong. It's meant to be plus x cubed because there's 2 negatives here. Okay, so put in the brackets to avoid making mistakes there. This is y2 minus y1, x2 minus x1. And as usual, we know the x's will cancel out. X minus x. There's the h. Your job? Simplify it. Expand the brackets on the numerator, and then simplify it down. Okay, so the question is, does anyone remember how to expand a plus b cubed? How do we expand that again? Anyone remember? Expansion of perfect cubes.
Isn't it like a to the power 3 plus a to the power 2 b plus b to the power 2 a plus b to the power 3 and yeah.
I'll write it down. Look. Equals 2a cubed plus, it becomes then 3a squared b plus 3ab squared plus b cubed. Pascal's triangle, if you've forgotten it, the coefficient 0, and then, oh sorry, it's 1, 1, 1, 2, 1, 3, 3, 1. That's why I knew it's 1, 3, 3, 1. I'm sort of teaching you a bit further now. This is called binomials theorem. But notice I went from A3, A2, A, A0. Whereas B, B0, B1, B2, B3. That's the pattern. Yeah? How do you know the coefficients? Pascal's triangle. So it starts off with 1, then 1 on each side. Okay, so you get your 2 there. And then to get your 3s, it's 1 on each side. 1 plus 2 is 3. 2 plus 1 is 3. You want to do the next one, it's 1 plus 3, 3 plus 3, 3 plus 1, and 1 on each side. Okay, that's how I know the coefficients of each one. Okay? But that's how you expand a plus b cubed. So meaning this. Just be careful that minus. That's the only one that usually gets students. So if it doesn't work out, it's likely you made a mistake with your minuses. Okay, so when you expand that, just be careful there. I know we're almost running out of time. There's only 2 minutes left. I'll talk about this again in the second session, and I'll work with Powell rule and chain rule. But ideally, at the end of the day, what I want you to understand was you're just finding the gradient of a straight line. You can just keep in mind that. I know we're going to start slow, but once you get the basics, we'll skyrocket up. You can do chapter 10 easily if you understand what I'm saying. Yeah, chapter 10 is just all theory. It's all the theory application-wise. If you don't understand the theory, the application gets difficult. You can all do year 9 maths, you can all do linear equations. It is possible to do. 2/3 of the course is on this idea. Okay, so if you get your head around it, 2/3 of it's done. the other part is knowing your functions, which I'm hoping that you guys did your test and you felt a bit more confident with it. I'll mark through it and I'll see your notations, I'll read it. Hopefully it's good, because chapter 1 and calculus, you put those two together, you're good for the exam.
Like,
It's
really?
a big chunk out of it, yeah. A massive chunk. Knowing your functions.
How much percentage-wise?
Oh, so huge. Because you think about all the functions, circulars, tan, sine, cos, tan, quadratics, cubics, quartics, square roots, 1 on x. If you can do all that for range, domain, and calculus, you're knocking out methods out of the ballpark. Okay, so get your head around that. Domain, range, set notation. It's so important where you get inverse functions, all that. Massive part. It does feel like it's 60-something%. Alright, we'll continue on next session, but thank you. If you haven't given me chapter 1, please give it to me. I'm going to try to mark it all today so I can give it back to you on the Wednesday, ASAP, so you can read my notes.